Good morning students. In this video we are going to see Unit 1 Laws of Motion, page number 15, Hard Questions. Roman number 9, Hard Questions. Question number 1. Two blocks of masses 8 kg and 2 kg respectively lie on a smooth horizontal surface in contact with one another. They are pushed by a horizontally applied force of 15 Newton. Calculate the force exerted on the 2 kg mass. That is, two masses of 8 kg and 2 kg both are lie on the horizontal surface and both the masses are in contact with each other. Now in this 15 Newton force is applied on 8 kg mass. We have to find out the force exerted on the 2 kg mass. How much force is exerted here? 15 Newton. The 50 Newton force is applied on 8 kg. We have to find out the force produced by the 2 kg mass. So, given data, mass of the block M1 is equal to 8 kg and mass of the block M2 is equal to 2 kg. The force applied is 15 Newton. So, we have to find out the force exerted on 2 kg mass. The formula to find out force is F is equal to ma. That is Newton's second law formula. Force is equal to mass into acceleration. The solution for this problem, by Newton's second law, F is equal to ma. Here two masses are given. So, we have to write it as F is equal to m1 plus m2a. Now, what is m1? It is 8 and m2 is 2. A we have to find out. And then the force applied on the object is 15 kilogram ms minus 2. So, 15 kilogram ms minus 2 is equal to 10a. Now, from this we have to find out a. So, a is equal to 15 kilogram ms minus 2 by 10 kg. In this kg and kg get cancelled. So, the remaining term is a is equal to 15 by 10 ms minus 2. Now, we have to divide this, we get 3 by 2. So, 3 by 2 ms minus 2, that is a is equal to 3 by 2 ms minus 2. Now, force exerted on 2 kg mass, that is F1 is equal to m1a, and what is m1? It is 2 kg into 3 by 2 ms minus 2. Now, here 2 and 2 get cancelled. So, the remaining term is 3 kg ms minus 2 or Newton. So, force exerted on 2 kg mass is equal to 3 Newton. So, in the result we have to write force exerted on 2 kg mass is equal to 3 Newton. And then question number 2, a heavy truck and bike are moving with the same kinetic energy. If the mass of the truck is 4 times that of the bike, then calculate the ratio of the momenta. That is, truck and bike are moving with the same kinetic energy. The kinetic energy is same. The mass of the truck is 4 times that of the bike. While we have to compare the mass of the truck and bike, it is 4 times that of the bike. We have to find out the ratio of the momenta. The ratio of the momenta is 1:2. So, in the given data, mass of the truck is equal to m1 and then bike is m2. This is we have to consider. So, the mass of the truck let us take as m1 and mass of the bike let us take as m2. And mass of the truck is 4 times that of the bike. It is given in the question. How many times? 4 times. So, we have to write it as 4m2. We have to find out ratio of momenta. So, the formula to find out ratio of momenta is kinetic energy is equal to half mv squared. So, the solution for this problem, here the kinetic energies of both truck and bike are same. So, we have to write it as 1 by 2 m1 v1 square is equal to 1 by 2 m2 v2 square. That is, the kinetic energy of both truck and bike are same. So, we have to consider that truck has mass 1 and bike has mass 2. So, let us write like this, 1 by 2 m1 v1 square is equal to 1 by 2 m2 v2 square. In this 1 by 2 and 1 by 2 get cancelled. So, m1 v1 square is equal to m2 v2 square. Now, already we know that what is m1? The 4 times of the bike. So, we have to write it as 4 m2 v1 squared is equal to m2 v2 squared. Now, in this m2 and m2 get cancelled. So, the remaining term is 4 v1 squared is equal to V2 squared. Now we have to write like this, V1 squared by V2 squared is equal to 1 by 4. That is, we have to bring the velocity one side and numerical value to another side. So V1 squared by V2 squared is equal to 1 by 4. Now we have to remove the square on both sides. So we have to write it as V1 by V2 is equal to 1 by 2. Now V2 is equal to 2V1. We have to cross multiply this, V2 into 1 and 2 into V1. So V2 is equal to 2V1. So the ratio of momenta, now we have to find out ratio of momenta. We know that the momentum letter is P. P is the linear momentum. So P1 by P2 is equal to M1 V1 by M2 V2. So what is M1? 4 M2, and then we have to write V1 as it is, and M2, and what is V2? 2 V1. Now in this, M2 and M2 get cancelled, V1 and V1 get cancelled. Now we have to cancel the 4 and 2, we get 2. So P1 by P2 is equal to 2 by 1. So we have to write it in ratio. Ratio of momenta P1 is to P2 is equal to 2 is to 1. Now next question. Wearing helmet and fastening the seat belt is highly recommended for safe journey. Justify your answer using Newton's laws of motion. So wearing helmet is highly recommended for safe journey. So what is the reason why we are wearing the helmet? When you fall from your bike on the ground, you will fall with a force equal to your mass and acceleration of the bike. That is, when you fall from the bike on the ground, we have to fall with the force equal to your mass. Suppose if your mass is 30 kg, means we have to fall with our equal mass, and also the acceleration of the bike, that is the speed of the bike, based on Newton's second law. That is, the mass and acceleration both are directly proportional according to Newton's second law. If the mass is increases, the force also increases. If the acceleration increases, force also increases. So if the mass and acceleration are greater, then the force also greater. So according to Newton's third law, an equal and opposite reacting force from the ground is exerted on you. Now here we have to apply the Newton's third law. So when we apply the force on the ground also applied the force to you. So it is in the opposite direction but equal force. So when we apply a greater force, the ground also apply the greater force, but it is in opposite direction. So wearing helmet will reduce the effect of force exerted on you and save us from fatal head injuries. So it is important to wear helmet for the safe journey. So it is very, very important to wear helmet for the safe journey. So fastening the seat belt is highly recommended for safe journey. So we have to wear the seat belt. So what is the reason? When our vehicle comes to a quick stop, by Newton's first law, we move forward and stay in motion until an unbalanced force acts upon it. So here we have to apply the Newton's first law. So if a driver suddenly apply a brake, we have to move forward. So and stay in motion, an unbalanced force acts upon it. So if we do not wear a seat belt, we would get hurt during this motion. So if we wear a seat belt, the seat belt gives an unbalanced force that would stop us from being in motion. So when we wear a seat belt, we cannot move forward when a driver suddenly apply a brake. So it is safe to wear the seat belt. Thank you, students.